Hello, welcome back to Project Too Easy. Today we're continuing revision for Heat and Electricity Year 9. If you haven't seen the first video in this series, then be sure to check it out. But with all that out of the way, let's get started. So, electricity is a type of energy produced when electrons and protons are separated and reunited in a closed circuit. Atoms are made out of protons, which are positive, neutrons, which are neutral, and electrons, which are negative. Protons and neutrons are found in the nucleus of an atom, and electrons are found outside the nucleus. For example, the atom to the left here has 3 electrons and 3 protons. This makes it a neutral atom, an atom with equal protons and electrons. When an atom has an uneven ratio of protons to electrons, it becomes charged, either positively charged or negatively charged. Here is an example of a positive atom. So if there were more protons, which are positive, than electrons, which are negative, then the atom will become positively charged. So you see here we have 3 protons, 2 electrons, and 3 neutrons, which means it is a positively charged atom. And on the right here, we have a negatively charged atom. So if there were more electrons, which are negative, than protons, which are positive, then the atom will become negatively charged. And see here we have 4 electrons and 3 protons. Static charge. So, like charges, so similar ones, so like a plus and a plus or a negative and a negative, they repel each other. Different charges attract each other, so a positive and a negative, they attract, and a charged object attracts a neutral object. So something that's charged with either negative or positive will attract a neutral object which has no charge. Electrical current. Electrons move through a wire. This is called a current. Conventional current is the path from the positive side of the energy source to the negative side of the energy source, as you can see here. And the electron flow is the path from the negative side of the energy source to the positive side of the energy source. And here are the circuit diagrams. So each of these is a commonly used symbol for components of a circuit. Next up, types of circuits. Excuse my horrendous drawings, but I couldn't be bothered to make a diagram because they take a long time to make. Anyway, series circuit. All components connected one after another, charge is shared among components, components cannot be controlled individually, and current stops flowing if a component blows. And a parallel circuit. A number of branches with their own components. Each component receives a full amount of energy, and only one branch is affected if all components blow. Electrical current. Amperes are a measurement of current. It is measured using an ammeter and is the amount of charge that flows past a point in 1 second. Resistance. Resistance is the measure of how difficult it is for electrons to flow through a wire. High resistance means it's hard to pass through a wire. It's measured in ohms, with the omega symbol right there, and wire thickness, material, and length all affect resistance. And finally, voltage. Voltage is a measure of the amount of energy supplied from the electron source. It is measured using a voltmeter and is the amount of push given by the electrons. Here are our V equals I times R calculations, and you can just pause the video and write those down if you want. Thank you for watching. I hope this was helpful in revision or learning this stuff for Year 9 Science. Be sure to like the video if you enjoyed and comment any other topics you'd like me to cover. As always, I'm Project Too Easy, and it's been nice. See ya.